Molar volume. Molar volume is the volume occupied by 1 mole of an ideal gas. Now the volume occupied by 1 mole of an ideal gas, of course, is going to depend on the temperature and the pressure. The molar volume, in particular, the molar volume is defined as the amount of volume occupied by an ideal gas at standard temperature and pressure, or sometimes called STP. STP is 0 degrees Celsius and 1 atmosphere pressure. So the molar volume, the volume occupied by 1 mole of an ideal gas at standard temperature and pressure, is 22.4 liters. How did I know that? Do I carry that number around in my head? Not normally. What I would do is calculate it. Because we have the ideal gas law, we can rearrange for volume per mole. Volume per mole equals RT over P. If I plug in these special conditions at standard temperature and pressure, R, of course, is the gas constant, 0.08206 liters atmospheres mole Kelvin, times T. 0 degrees Celsius, of course, we always express that in terms of absolute temperature, so I'd have to add to that 273 Kelvin to make that 273 Kelvin. 273 Kelvin divided by the pressure, 1 atmosphere. The units cancel, leaving us with the liter per mole, and the value is 22.4 liters per mole. This is an important number because anytime you have 1 mole of a gas, you know at these conditions it's going to occupy 22.4 liters. Here's another volume-mole relationship. A helium weather balloon was filled at negative 20 degrees Celsius to a volume of 2.5 times 10 to the 4th liters with 1.2 times 10 to the 3rd moles of helium. So what this statement means is that the balloon that was this volume contained this many moles, 1.2 times 10 to the 3rd moles of helium. And the question is, what is the molar volume of helium at negative 20 degrees Celsius? Okay, so since we're not at standard temperature, chances are I can't just say the molar volume is 22.4 liters. Rather, in this case, because my conditions are different, I'm going to have to calculate it. And the way I can calculate it is based just on the definition of molar volume. Molar volume is that volume of the gas occupied by 1 mole of the gas. So in this case, I know the total volume and I know the total number of moles, so I can just divide to figure out the molar volume. In other words, the molar volume is equal to the volume in liters divided by the number of moles of the gas. So filling in what was given here, 2.5 times 10 to the 4th liters divided by 1.2 times 10 to the 3rd, whoops, that's a 10, 10 to the 3rd moles, that is 21 liters per mole. So in this case, 1 mole of this gas under this condition occupies 21 liters. And that makes sense because negative 20 degrees Celsius is 20 degrees less than the standard temperature of 0. In this case, we're assuming that pressure was 1 because it wasn't otherwise given. But it doesn't matter because this is the conditions that they are. All we need to do is divide the given volume of the gas by the given number of moles of the gas. And in this case, it's 21, which makes sense, as I was saying, because it is colder. And we know that volume and temperature are related, directly related. If the temperature goes down, the volume is going to go down. So it's 21 liters per mole in this case.